Go over this as a group, as a class, and then we'll get started, and then we'll do a delta activity with you guys, and we'll finish it off. Is that cool? So don't worry, guys. We'll be pretty quick. It says use exponents to condense the. All right, guys, focus. Use the exponents to condense the expression below. So condense. So that means we're gonna reduce this, right? This is a product. How many x's do you count? So there's gonna be x to the what? Yeah, x to the fifth, x to the 5. It's all good. How many z's do you see? So we're gonna say z squared, or z2, I guess. Z to the 2. Cool or not cool? Yeah, that's it. Look at the next one. This one says to expand. So I want to make sure that it's a product. This says x cubed. So how many x's am I going to write? 3. You could put the dot in between, or just like that. That means product there. How many z's am I going to write?
6.
So there it is. 1, 2, 3, 4, 5, 6. And that's it. Pretty straightforward. Nothing crazy, right? This says to condense. How many z's do you see? So z to the 6. And we're done. Chavez, I need a calculator to do 16 times 9. I mean, I guess you could, but here's how I do it. And then you tell me, there's so many different ways to do it. The way I do it the first time around, 16 times 9, I do 16 times 10 first, because I can do that one pretty quick. 16 times 10 is 160. And then, but that's not 16 times 10, that's 16 times 9. So I'm going to subtract 16 from the 160. I can do that. Let's see, I do it in steps. 160 minus 10 is 150, and then minus 6, 144. So I see 144. You don't have to do it that way. If you want, you could have done 10 times 9, that's 90. And then 6 times 9, that's, what's that? 54. And then 90 plus 54 is 144 again. So see all the logic that you got to use, guys? It doesn't matter how you do it. Just, use the logic of what you think is easiest. And then I have x to the 4th times x cubed. What am I going to do to those exponents? Yeah, I heard someone whisper it. What is it? Yeah, add them to the 7th power. There's a safe space, guys, and it's okay if we're wrong. We make mistakes, it's fine. No one's going to say anything crazy. We're just going to say, oh, no, try again. What's y squared times y to the 4th? There it is. It's all a product. Pretty easy, guys, nothing crazy. Right, yeah, and stop me if I'm going too fast, or if we need some better explanation. All right, what is 6 times 8? 48. So I write 48. And then I'm multiplying here, x to the 4th times x cubed. What am I going to do to those exponents? I'm going to add them. And then y to the 4th times y squared. Y to the 6. There it is, guys. Ready for question number 6? 11 times 12. Well, I don't know. 11 times 11 is 121. So 11 times 12, I'm going to add 11. So 132. Right? 121, 31, 32. Yep, there it is. Positive times a negative. Negative, so put a negative in the front. I have 1x here, and I have another x there. So it's going to be x squared, and then y squared. And that's it. What do you guys think? Not bad, right? Not bad. Sorry, I don't know why I said it like that. All right, here we go. I have this parenthesis here. Delta math is going to want you to simplify it. It does say simplify. So first I'm going to write it like this. 3 to the 5th. X, I'm just using the property of power to a power. X to the what power? 10. Yeah, because it's a power to a power, guys. And then y to the 5th. Y to the 5th. That's like a power 1 right there. Are we okay with that? No, hit me. Okay. All right. Let's simplify that 3 to the 5th. So let's see. 3 to the 5th means 3 times 3 times 3 times 3 times 3. I know 3 times 3 is 9. And then, so this is 9 times 9. So I have 81 times 3. All right. Chop, how do you do 81 times 3 without a calculator? Well, I know 8 times 3 is 24. So 81 times 3 is 240. And then just add the 1 3 times. Plus 1 plus 1 plus 1. So it's going to be 243 x to the 10th, y to the 5th. There it is. Do you see how we did it without a calculator? Now, if you have a calculator, just use your calculator. But do you see the especially you guys that are going to be taking the TSI later on this year? Did you guys already take it? No, you will be, and you don't have a calculator. Oh, I think you might have a 4 function, but for the most part, you don't have a calculator. So there's the logic of how you can do it. Could you have done like, well, okay, I'll stop. because I don't want to overcomplicate it. All right. This one right here, -3 to the 4th power. Anytime you're raising anything to an even degree, if it's negative, it's going to turn into a positive, because negative times a negative times a negative times a negative is a positive. Does that make sense? So let's see. -3, well, forget the negative. Drop it down. 3 times 3 times 3 times 3. Well, that's going to turn to 9 times 9, which is just 81. Do you see how we did it, guys? And then x to the 5th raised to the 4th, that's going to be x to the 20. And then y to the power 1, technically, raised to the 4th is going to be y to the 4th. Look at you guys being beasts. Were you guys this beast when you guys were in Algebra 1?
Yes, we were.
Heck yeah, you were. Well, and if we weren't, we're beasts now. See? Does everything make sense, guys? So that's the key. If you can explain it to someone simply, then you actually got it. So yeah, and don't be scared of it's Quinones. All right, here we go. I thought we did this one. Oh, I guess we didn't. So -4 raised to the 4th power 4. I guess I'm just going to leave it right now for 4 to the 4th. In a little bit, I'll take it out. Chop, what happened to the negative? Negative raised to the even powers turns to a positive. Are we still okay? X to the 12th. And then y to the 20th. All right, let's see. What is this 4 to the 4th? Well, 4 to the 4th, that's 4 times 4 times 4 times 4. Well, I know 4 times 4 is 16. So I have 16 times 16, which is 256. And there it is. Yeah, sorry if I said it a little weird there. Yeah. How do we feel, guys? Not bad, right? Not too shabby? Not too shabby. Okay, I'll stop. N squared raised to the power 5, or raised to the power 5th. So that's going to be n to the 10th. Yeah, that goes back too easy now. Question 11, we're multiplying here. What do I do with those powers? We're going to add them. Yeah, no, if it's, we're going to add them if it's a product. We multiply it when it's power to a power. You know what I mean? Like if it would have been c cubed raised to the 4th power. So, and it is a safe space, guys, so it's okay. It's okay. 4, 5, 6, 7. We're good. All right, next one. What's k times k to the cubed? K to the 4th. Yep, there it is. No, not K-pop. Did I hear someone say K-pop? All right. Yeah, that's it. That's it. We're almost done, guys.
That's not true. Yeah.
Well, look, there's not even that many. We're almost done. We're 1/3 the way. See? There, that's true. All right, here we go. It says evaluate, express. All right, guys, focus. Express your answer as a whole number or a fraction in simplest terms. So that first, I don't want to see that negative exponent. So this is like 7 - 2 over 1. How do I turn that negative exponent into a positive? I don't know, Chav. Yeah. Remember, okay, let's remember real quick from Monday that if we had x to the -2, we could have turned that into a positive by bringing it down like that. Do you guys remember? Yeah, you can use the word flip-flop. So does that make sense to you guys? So yeah, so here we go. So I'm going to turn that to a positive by bringing it down. I'm going to when I say turn it into a positive, I'm turning the exponent into a positive. 1 over 7 squared. All right, what's 7 squared? So this is the answer. That's what they want. See? All right, let's go to the next one. Anything raised to the 0 is just going to be what? 1. Not Juan. 1. I thought I heard someone say Juan. A long time ago, Juan, if you're seeing this, his last name was Mr. Cardenas, but his first name was Juan. And every time, I don't know if you guys know this, but do you guys know that sine of pi over 2 is 1? Or cosine of 0 is 1? Well, okay, anytime there was an output that was 1, I'd always go, Juan? And because he was sitting right in front of me, and he'd be like, and I'd look at him, and he'd look at me, and we'd just look at each other, and I'm like, what? And then, yeah, he was so funny. I miss him. I hope he's doing well. All right, you guys ready for the next question? Same thing, guys. Sorry, should I leave that I'm recording this. Should I leave this on my video? Yeah, 1 over 11 to the power 1. So just 1 over 11. Are we done with those style questions? Yeah. Okay. Number 16. Anything raised to the power 0 is 1. Juan. Any of your guardians named Juan? Yeah, don't call him Juan. All right. Okay. Once we become more experts, probably when you guys reach pre-cal, I would probably just tell you, just take the reciprocal on this. but we're not there yet. So we'll use the rules that we learned on Monday. So what did we learn on Monday when we have something raised to the power like -1? We're going to put this like this. You guys remember that? That property? So there it is. And now I want to turn those exponents positive. So the 1 in the numerator 9 to -1, I'm going to bring that down. And the 20 to -1, I'm going to bring that up. So 20 to the power 1 over 9 to the power 1. Are we still okay? All right, well, 20 to the power 1 over 9 to the power 1, that's just 20 over 9. And then leave it alone. Does that make sense, guys? All right, let's keep going. All right, so we have 1/2 to the power -2. So our basic properties, we're going to go 1 to the -2, just like what we learned on Monday. 2 to the -2. Are we still okay? All right, I'm going to turn those exponents positive. So I'm going to bring that to -2 up. So 2 squared, and then over 1 squared. And then what's 2 squared? 4. And then 1 squared is just, so it's the same thing as just saying 4. Does that make sense to you guys? All right. Oh, look, we're almost done. Now we are almost done because we just got this last page. All right. Hey, little Volpert. Oh, big Volpert. Hey, Volpert. Yeah, the little Volpert is her daughter. So, yeah. All right. All right, guys. Let's focus. I don't know why they're looking at us here, but they're putting you there. All right. Here we go. So it says select the equivalent expression. So you see x squared times x squared. That's going to be x to the 4th. And I'm going to leave that y alone, and I'm going to write y over -4. Now I'm going to do this 2 different ways. Here's way number 1. That's a 4 there. Just looks a little funny. All right. Method number 1. Remember yesterday I told you that if we have x to the power m over x to the power n, what do we do? X, that's just x to the power m minus. Do you guys remember that?
Yes.
Okay, well, if I do that, let's see. This is power 1, so I have x to the 4th. And then what's 1 minus a -4? Well, that minus here turns to a plus. So this would be, no, not -3. 5, because it's 1 plus 4. Do you see that? No, it's okay. It's okay, miss. Relax. We're good. It's okay. We're turning beast mode. We're getting better. All right. So 1 minus, anytime you have a minus like this, it turns to a plus. So there it is. So I'm going to write y to the, okay. Do you guys like that one? Or maybe you like this better. So I'm going to start right here again because I already did the x squared times x squared. So here's method 2. So x to the 4th y over y to the -4. So here's method 2. You see this y to the -4? I can turn that positive by moving, I can turn the exponent positive by moving it up. So look at this, x to the 4th, y to the power 1, y to the power 4. And now look, these two have the same base, y, and when I multiply those, you're going to add the exponents, and what's 1 plus 4? So x to the 4th, y to the 5th. They both give you the same answer. Which one do you like best? Yeah, it just depends, whatever you like. You do you. So you do the one that you prefer. Does that make sense, guys? Okay. All right, let's look at this one. Since I heard some of you say that you want positive exponents, that's what I'm going to do. So that x to the -3, I'm going to bring it down to turn that exponent positive. And that x to the -5, I'm going to bring it up. I'm going to put it to the numerator so I can turn that negative into a positive, the exponent into a positive. Does that make sense? So now I have this, x to the 5th times x squared over x cubed. Are we okay right here? All right, now I'm going to go ahead and multiply the numerator. X to the 5th times x squared. I'm going to get x to the what power? No, not 10th, 7th. Yeah, well, maybe I'm confused by saying multiplying. I'm saying when I say multiply, it means that these are being multiplied. But when you multiply the same base, the exponents, you add them. Over x cubed. And now, what do I do to get my new answer? I got to do what? Yep, 7 minus 3, which is x to the 4th. Yep. Are we okay so far? Okay, we're almost done, guys. We just have a few left. All right, I have x to the 7th over x to the 8th times x to the 7th. Look at those x to the 7th. You could, if you wanted to, add the denominators up at the exponents, and they're being multiplied. But don't, let's work. What is it saying? Work smarter, not harder. I see an x to the 7th in the top. I see an x to the 7th in the bottom. Multiplying and dividing are inverse operations, so I can just cancel those. Do you guys see what we did? All right. Notice that I have x to the 8th in the denominator, so you got to keep it in the bottom. So there it is. And then what's going to be my answer choice? Letter A. Do you see how we're doing it, guys?
I have a question.
Yeah, hit me.
Why is it not number like letter D?
Yeah, no, good. No, thank you. Hit me, miss. So it can't be letter D because you see how I still have x to the 8 here in the bottom? Yeah, that's this one, right? Yeah, no, you're good. You're good. It can't be letter D because x to the 8th is in the denominator. So you got to keep it in the denominator. If you were to just write x to the 8th, that's like saying x to the 8th over 1. But notice x to the 8th is not in the top. X to the 8th is in the bottom of the fraction. So you got to keep it in the bottom. That makes sense? Okay. All right, here we go with this one. Focus on the coefficients first. How many times does 4 go into 20? So write 5 first. And then I have x cubed in the top, x squared in the bottom. How many x's can we cancel? Yeah, we can cancel 2. Yeah, you're giving me the answer, I think. So that means you have 1 left. It's in the top, so 5x. And all 5 of those y's are going to cancel out. Don't worry, we're almost done. I heard a sigh. Relax. We're gonna finish in a little bit. Are we okay, guys? I know. Are you guys tired? Yeah. After lunch is always hard. So you want to try to take. Here's when you take math courses, you want to try and take math courses before lunch, because after lunch taking a math course is brutal. So try to take it before lunch if you can. Yeah, hit me.
So when we, like on the one up, we did 20 divided by 4. So when it's in a fraction like that, we always divide it.
Well, because the 4 is in the bottom. So this is like saying this 4 and 20. See? So 4 times 5 is 20, and then so there it is. So that's the answer. But if it would have been like this, 4 over 20, 4 goes into 25 times, it would have been 1/5. That makes sense? Yeah. So this is just a side note. Did I answer your question or no? Okay. Yeah, ask me, guys, ask me. It is a safe space. Okay, so look at this one. So this is gonna be perfect for you guys. There's 2 ways to do this. You can always do, anytime it's even over even, you can always divide by 2 and keep making it smaller until you get to the smallest number possible. But we'll show you this route, and then the other one we'll just go by 2. So the biggest factor that goes into the 20 and the 30 is 10. How many times does 10 go into 20? So I'll write 2. How many times does 10 go into 30? So that reduces to 2/3. Do you see what we did? All right. I have x to the 5th over x to the 4th. How many can I cancel? 4 of them, and I'm going to have how many left? So 1x. So there's my 1x. Y to the 7th in the numerator, y to the 8th in the denominator. How many can I cancel? All 7 of those. So I'm going to have 1 left, but that 1 is in the denominator. So put it in the bottom. Did all that make sense? Okay. Let's go to number 24. All right, so here it is. You could do this with the greatest common factor as well, just like we did last time. But let me show you another hack. Ready? Is 12 even? Is 20 even? If it's even over even, you can always just keep reducing it. So watch. How many times does 2 go into 12? 6. How many times does 2 go into 20? 10. Okay, are these 2 numbers still even? Is 6 even? Is 10 even? Let's keep reducing it. How many times does 2 go into 6? How many times does 2 go into 10? There it is. That's it. You can't reduce it any further. You could always do that. Do you see what we did? Okay, so hopefully your SAT and ACT scores are going up, and especially your TSI. Hit me.
Number 23 said the fully simplified using only positive exponents.
Yeah, they're positive, I think.
Oh.
Yeah, that's positive 1. That's positive 1. But no, please hit me. Anytime. Yeah, because if I would have brought that up, it would have been a negative exponent. If I would have brought it up, it would have been negative. But there it is, positive exponent. Oh, yeah, you're good. All right, here we go, guys. I have x to the 7th. I got to be careful. Saying 7x is not the same thing as x to the 7th, so just be careful. X to the 7th over x squared. How many x's cancel? 2. And I'm going to have 5 left in the numerator. Are we still okay? All right, I have y to the 8th over y to the 4th. How many y's cancel? 4. All right, focus. Come on, Miss Dillon. 4. So y to the 4th. There it is. Are we cool, guys? All right, let's go to the next one. All right, so I need everyone's attention for these because these are the brand new ones for you guys. So put a side note, and I'm going to say this. This is in the form of y equals a times b to the power x. What do we call this form? This is called exponential form. Are we still okay? Okay. Has anyone ever made copies in the copy machines where you had to make it bigger or smaller, the scale? No? Or anyone had a job that required? Okay. If you ever do, you're gonna push a little plus button. Like let's say, I don't know, let's say someone tells you go make a copy of this, but make it bigger. So then you put it in there and then you push the plus button on to magnify it, and you're gonna see a little percentage, and that percentage is gonna go above 100. And if it goes above 100, it makes your image bigger. Does that make sense? And what do you think happens if I push a minus sign and that percentage goes below 100? It's gonna make my image smaller. So that's called scaling. So this 1.85 is like a percent. Like a percent. So what is that? That's like saying 185%. Does that make sense to you? All right, so think about it. So let's see what this question says. It says, given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease. All right, so if you blow something up to 185%, 185%, is this growth or is this decay?
Growth.
It's growth. So I'm going to write the word growth. And then it wants to know by how much. Well, by what percentage did it increase? So your reference, it's always 100% as a reference. So how much bigger is this than 100%? 85. So it increased by 85%. 85% rate of increase. Percentage rate of increase. Does that make sense? Okay, so you're always going to reference it to 100 or to the value 1. 100% is the same thing as saying 1 in decimal. All right, so here we go. Don't freak out. That 0.1 is similar to what percentage? No, not 1%. 10%. Move the decimal 2 times to the right. So is this growth or is this? It's decay. Perfect. Now remember, we're going to reference it to 100%. So this is 10%. What is the difference between 100% and 10%? So that's what you're going to write. 90%. It decreases rate of decrease. 90% decreased. Rate of decrease, yeah. Rate of decrease. Does that make sense to you guys?
Yes.
All right. Here we go. One more. Is this growth or is this decay? Decay. So write decay. And this is like 18%. So what is my rate of decrease? 82%. Rate of decrease. Does that make sense, guys? All right, good job. You guys are all stars. So do you guys have your laptops? Put some music.